In this video, we're going to be proving that n squared is less than 2 to the power of n for all n greater than or equal to 5. We're going to use mathematical induction to prove that. So, mathematical induction entails two steps. The first one is the base step. And for the base step, we're going to let n take the lowest possible value it can take according to our problem. So, it's equal to 5. And we're going to see if our relationship holds. So it's going to give us 5 squared less than 2 to the 5. Is that true? So this is 25 and this is 32. So this holds. So our base case is fine. Now we move on to the induction step. And for the inductive step, we're going to be saying first that the induction hypothesis holds. And the induction hypothesis is basically that k squared is less than 2 to the k for any k greater than 5. So we're going to assume that this holds. And then we're going to go on to prove that k plus 1 squared is less than 2 to the k plus 1. So we've just incremented k. So now we're trying to prove the step, being able to actually go from k to k plus 1, given that k has been proved. So this is what we're trying to prove right now. So let's start with from the left-hand side. So the left-hand side is k plus 1 squared, which is equal to k squared plus 2k plus 1. And of course, if we look at our induction hypothesis right here, we see that k squared is less than 2 to the k, and that was our assumption at the beginning, and we can assume that it is true. So what we're going to replace that by, we know that this is less than 2 to the k, right? So this entire thing will actually be less than 2 to the k plus 2k plus 1. And the right hand side, if you look at it, is basically 2 to the k times 2, right? Or 2k plus 2 to the k. So 2 times 2 to the k, right? So you try to compare these two expressions. This is our left hand side and this is our right hand side. We're trying to prove that the left hand side is less than the right hand side. Well, you see that we have this in common, and these are the only two things that we have to show. So we have to show that 2 to the k plus 1 is less than 2 to the k. So we've reduced our problem right here to this relation. Now, how are we going to go about proving this? Well, we're going to be using mathematical induction one more time. So we're going to have a base case in this case, and you're trying to prove this for all k greater than or equal to 5. So our base case in this, for this proof, is going to be letting k equals to 5, and we're going to say that 2 times 5 plus 1, is it actually less than 2 to the 5? This is 11 and this is 32, so this is correct. Now we can move on to the next step, which is in the inductive step. For the inductive step, just like we did in the earlier problem, we said that, of course, this is a sub-problem that we've derived from the earlier problem. So when we prove that, we're going to be able to actually just say that this is right. So we're kind of like subdividing our problem. And at this point, the inductive step will basically be that first we have an induction hypothesis, that is 2 to the b plus 1 is less than 2 to the b for any b greater than or equal to 5. So this is going to be our induction hypothesis, and what we need to prove is that 2 to the b plus 1 plus 1, so I'm just incrementing this, is less than 2 to the b plus 1. And here we could expand that, and we get 2b plus 2 plus 1 is less than 2b plus 1. So we're trying to actually prove this. We don't know if that is correct or yet. So if you look at this, you have a 2b plus 1, which is essentially that expression right here, and that's less than 2 to the b by the induction hypothesis. So we can replace that by 2 to the b plus 2, since this is going to be less than that. Sorry, this is going to be less than that, and effectively we have this, and this is just, the right hand side is basically just 2b plus 2 to the b, and this is definitely less than that, so we've proved this case.